All right, where was I? So we are gonna go back to Cloudwatch today and talk about service level management. And we are also going to look at setting up service level management or service level objectives, I should say, inside of Cloudwatch and installing Cloudwatch agents on an EC2 so that you can send metrics from utilities like Netcat. There is not going to be an assignment today, given that the service level management stuff is kind of hard to implement a challenge for that, especially in a short amount of time. We'll dive more into the why behind that when we get into the lesson. But um, for today and the rest of the week, there are still challenges that I don't think many of you have completed. So that will be the scope for the rest of the week. Reno, Preston, and Chandra will circle you back through the Elasticsearch stack, Kibana, and be available for assistance with those group challenges. One of them is, I think, setting up monitors with the assessment 2 setup that you've created. And another is running through Java Spring Boot application and using Kibana and FileBeat to monitor that, and then setting up a Python Flask application. That said, let me share my screen and we could dive into today's lesson. Okay. I might actually want to share this entire screen and not just the window. So let me find that. I've also got a bunch of windows to close out, so give me 1 sec. Okay. I think this is good. All right. So service level management and Cloudwatch. Ultimately, service level management is a high level practice that you're probably not going to be too concerned about initially. Even if you land in an organization where service level management is practiced, it's very likely that it will already be implemented. So it's a kind of practice where its value will directly correlate with the scale of the organization itself and the number of its dependent users. So service level management is more critical for large companies like Google, Uber, and Netflix than it would be for startups or smaller developers. We're still going to be covering it anyway because it's a critical part of site reliability engineering, which is one of the branches of DevOps that you can go into. And it ties into what we're learning so far with monitoring. You could think of service level management as taking what we're learning in this monitoring section and really crank it up a notch. It's adding a lot of complexity, which will create a lot of additional nuance in how you're able to observe your applications. So service level management consists of 3 components. You'll have your service level agreements, which are the, well, agreements between the customer and the service provider. In this case, often in the case of an SRE, it's the SRE team that's the service provider, and it's the SE teams or other stakeholders in the organization that serve as the customers. And then there are the customers of the organizations themselves, like let's say with Netflix, the users of Netflix. So that's essentially the yeah, I guess the stream, right? So there are two levels of customers. There's the customers to the organization, but then there's the internal customers. So you as an SRE or a DevOps team that is employing service level management are providing a service really to that internal customer, right? You are making an agreement between yourself and the stakeholder that your application will behave within a certain let's say threshold. It's going to meet a certain guideline, and that's what your service level objective is. So if you think of the agreement as being the what of the goal, then the how of the goal will be the objective. The objective is what's going to be how you track whether or not you are meeting that agreement. So an example objective would be success rate. Is your application succeeding above a certain threshold? Are 95% of the requests that go through succeeding, or are they, or are more than that, or less than that succeeding, which means you're below your threshold? We use service level indicators to track that. So objectives and indicators work together to determine whether or not you're meeting the agreement, basically. Objectives can cover things like availability, latency, throughput, which is essentially like the bottleneck of how many requests the application or service can handle within a time window. And then there's correctness and durability, which pertains to the quality of the data that's available to the customer. Is it the right data? Is, for example, a link that says to retrieve a list of, I don't know, movies, because we've been talking about Netflix. Is that actually returning a list of movies, or is it returning a list of TV shows, right? That would be an instance um, where the request itself might be working, but the data is returning is not correct. And then there's costs. So are users behaving the way that they're expected to behave? Or are they facing unseen obstacles that could be hindering the organization or the application's ability to earn income and revenue, right? So these kind of goals are, well, the SMART framework works really well for creating these kind of objectives. So make your objective specific, measurable, achievable, relevant, time-bound. And this is very important because overall, designing SLOs, designing service level management in general can get pretty complicated, and it could be kind of overwhelming to folks that are new to it. But the trade-off is that you are creating a lot of value in the long run by ensuring standards that will give your engineers the ability to react more effectively, to make your applications more reliable and resilient to future incidents. Essentially, service level management allows for faster response, which translates into less revenue lost when incidents occur and happier stakeholders overall. So what are the indicators that you could use to track these objectives? It really depends. If we're talking about things like success rate, then we're going to want hard metrics like you'll take the number of times an API is called, and you'll take the number of times like that actually succeeds over the total amount of times it's called. That will give you a success rate. Likewise, if you were to take the number of times it fails and divide that by the total number of requests, which is the sum of the successes and failures, that's how you get your error rate. If you're working with latency, you're going to want a time-based metric that you could create using a monitor. So these are essentially the simpler of the metrics that are used to indicate whether or not you're meeting your objective. Where SLOs really get fancy is with their more complex metrics. So you're going to have things like your rolling time frame or window, or also known as an interval. I think that's what AWS calls it. You're going to have error budgets and you're going to have burn rates. And these might just sound like, I don't know, really abstract terms, which maybe they are, but once you get the hang of what they are and how they all relate, it really does make sense. So let's take a look at this chart right here. Let's say you have a very plain vanilla monitor, right? And that monitor is set to trigger an alarm every time your, I don't know, behavior of your application or service goes above this threshold. That would mean you would have been alerted, what, 1, 2, 3, 4, 5, 6, 7, 8 times, right? That could get very noisy. And the problem with noisy alerts is they make people unhappy, especially engineers who have to respond to them, especially if they're on call. And what happens is people develop a resistance to alerts. It's alert fatigue. They'll just start ignoring alerts, and nobody wants that because you never know when an alert can actually be very critical, right? So with a service level objective, with things like time frames, intervals, burn rates, and error budgets, you could have more dynamic alerting where basically, even if your service spikes and goes above a threshold, your alert is no longer written to just trigger when you go above that threshold, but instead, when you go below a certain error budget, right? Or if your burn rate surpasses predetermined speed. And what that looks like is this, for example. Here we can see two different charts, right? We have a budget and a burn rate. Both of these are existing in the same time frame, the same interval. Down here, we see that we have some spikes. They never actually, well, the first two don't actually surpass a target objective, but you could see, even though we have the spikes, we have a drop in the error budget. So basically, there should be another line down here that shows, because there are like essentially there are multiple thresholds here, right? You have a threshold that will trigger when one kind of alert will be raised, and then you have a threshold that will determine whether or not the error budget is used. So it looks like for this SLO, anything above like this 0 line will deplete the budget. So it's a very, let's say, I guess, picky SLO. When you are below, let's say, this threshold, this middle line here, if that's what that is, that's when you could have an alarm trigger. And what this allows you to do is to basically ignore an issue until you know that's going to be an issue, because there could be fluctuations in behavior, right? Like you might have spikes. It might be normal for your application to have spikes, and you might not want to alert on those spikes all the time. If we look at this, for example, we have a large spike here. It wasn't necessarily an issue, however, right? It's just like an anomaly. If it were to consistently happen, then it would deplete the error budget much faster, or much more, I should say. We're not talking about speed yet, much more. And once it goes down a certain threshold, then that's when we trigger the alert. So this is an example of how you could get a different remaining error budget based on your time frame. This is a 7-day time frame. So the budget for a 7-day time frame, the overall budget, is going to be smaller than a budget for a 30-day time frame. That's why you see that the remaining error budget here is 90% versus the 82%. And if we look down in this chart, we not only pick up this spike, but this smaller spike more than a week before, and this somewhat medium spike several weeks ago. And that is how you're able to create objectives that will react dynamically, right, to essentially what's happening. Here's another example. Let's say you have a bunch of spikes within 7 days. It might just spike enough that every time it spikes, it reduces your error budget down to a point that it triggers within 7 days. If they were more spaced out, or maybe even that in the exact same scenario, it might trigger the 7-day alert, but it won't necessarily trigger the 30-day alert because, again, the 30-day time frame has a larger budget. Now, what if those spikes were spaced out, like they were 7 days apart? This is a situation where it may not necessarily trigger the 7-day alert, but it would trigger the 30-day alert. And so really it boils down to writing good SLOs boils down to having good planning, being okay with refining over time, right? You might not get it right from the very get-go. It could be a little intimidating, given that you're working with like a lot of relationships between metrics here, and it's going to involve some math and it's going to involve trial and error. But over time, once you get the hang of SLOs, they make for a great additional tool in your repertoire of observability. So does that mean that they're supposed to replace monitors? No, they're supposed to work in conjunction with one another. In fact, you can't really have SLOs without monitors in the first place, right? Or metrics. So here's an example of a Datadog dashboard where we have some very traditional vanilla metrics, all returning data over time. And then we have a list of SLOs that will analyze this data in more complicated ways. And that's how we're able to create a range of alerts that will trigger in different scenarios, which will give an organization, a team overall, more coverage over the potential failures and incidents that can occur. Does that make sense? Cool. Let's take a look at setting up an SLO inside of Cloudwatch. It's actually pretty simple. They made it pretty simple. So here we are inside of, let me make sure that this is actually looking at the right screen. Yep. So here we are inside of AWS. And if we look at where we are, we're at Cloudwatch dashboards. If we expand this menu and we scroll down, we can see that they have, I guess, this new option for service level objectives. So let's click on that. Here we have an SLO that I've already created. It's healthy, but I think it's also connected to an EC2 that's been terminated. So that's why it's healthy. But let's break down what we're looking at here, right? First, at the very top, we're able to change and adjust the time frame. So we could read our data in, I guess, different ways, right? So we have right now set to 12 hours. It'd be nice if I actually had this set up to an EC2 that's been running all this time, but we're going to have to use our imaginations here. So this allows you to kind of play around with the amount of data that you're going to see. Like you saw in the screenshots earlier, we saw one spike in the 7-day window, but when we expanded to the 30-day window, we picked up 2 additional spikes. That's essentially what happens when you're playing around with your time frame. Now, this SLO was named utilization rate above 50. So I think this is the CPU utilization metric that's being tracked here, right? Let's actually, it might actually make more sense to just create an SLO and look at how one is set up that way. So like, let's say we give it a name. Let's just say CPU utilization um, below 50 or whatever. Like maybe you want your CPU to stay below 50, or maybe you want to name it above 50 because that's when you're going to trigger. It kind of really boils down to your use case, your organization standards. Here we set the type of metric that we want to monitor. So we don't really have any services set up, so let's just play around with a Cloudwatch metric. If we click here, then we're able to select from custom namespaces, which we'll talk about in a sec once we go into Cloudwatch, um, setting up Cloudwatch agent on an EC2. But traditionally, you'll be able to do work with built-in AWS metrics, right? So if we look at EC2, and we grab the ID of the instance we want to track. So in this case, I'm just going to copy this. I'm going to insert it here. We could limit the search. So instead of 1,800 metrics, we only have 17. And now we could select one of these built-in metrics to monitor. So let's look at, I don't know, yeah, because there's not really anything on this EC2. There's not really going to be a lot to look at. But look, we have some CPU utilization here. Looks like, what time is it now? 6 o'clock. We had activity bouncing around while I was, I guess, running different commands on there. Oh, right, to set up CloudWatch agents. So that's what that is. Let's select that metric. Now, once you've selected that, you can set a condition. So we've got our metric and we want to know when we are, let's say, below a certain threshold, right? Let's say once we're below 50, maybe let's actually change that. We'll just change that to 10. Not 5, 10, but 10. Actually, maybe 8. There we go. Just so we have something interesting to look at with the graph. So in this theoretical SLO, we are going to raise an alarm if we have a number of instances in which our utilization is above 8%. That's what this means. Now, you could set a period for when this evaluation runs. I think by default, it's going to be 5 minutes. And what's it say here? It does not support intervals smaller than 1 minute or larger than 15. So it's grayed out anyway, so we can't change it. And then you can set your interval. So here we have a 1 day time frame. So the error budget is going to be calculated off of just the events within the last 24 hours. If we change to 7, we could have it calculate over a 7-day period. But since we don't have a lot of data because this isn't a real application, let's just stick to 1 day. Now, attainment goal, I think that's essentially the equivalent of what we call a threshold at ANOVA when we are using Datadog. And basically, this is the percentage of the budget that you want to be above, right? So just because your application goes above this limit does not necessarily mean that it's going to trigger, right? Instead, it's going to burn through your error budget. And if we set this to something like, I don't know, 50%, then we are being very generous, right? Like we are essentially saying we could let our application fail for like 50% of the time of this 1 day, half the day, and we'll be fine. I mean, that's not a very great SLO to set, but just for the sake of explaining how to set one up, that's what we're going to leave it at. You could also set a warning threshold. So you could set an additional alarm that will notify you when you're getting close to the previous or the other threshold that you've set, which again is part of the idea of giving you a lot of flexibility and a lot of coverage over different scenarios and different ways to respond. So now you'll be able to set things like the various kinds of alarms that you want to trigger. In this case, we could set a warning alarm in addition to a more traditional alarm where just like a regular monitor, it will trigger if it's above that threshold, or we could have it trigger really when we burn through the error budget and hit a certain threshold. And then you can apply some tags, and that's how you create your SLO. All right, any questions? Cool. I know it could be a lot. So to sum up, let's actually just talk about the key takeaway, right? Right. So with service level management, really what I want you to take away today is that it's like an advanced practice, a very advanced practice that is utilized more by larger companies, and it consists of three things. Again, your agreements, your objectives, and your indicators. Don't, I guess, get too worried or bogged down by the specifics of like how you calculate error budget over time. If we had a challenge for you to start doing that sort of stuff, um, that's really when it would stick. I think just throwing it all at you now, that's exposure. I don't expect a lot of the math to stick. And it really won't need to until you're in a situation where you're going to have to write these SLOs, right? Is there, I think there might be one more thing I want to show you when it comes to SLOs. Let me see if I bookmarked this. I thought I did, but I might not have. Oh, yeah. Here's a cool, nifty little tool to, and a cheat sheet to kind of give you an idea of um, how to how to set up your SLO. Like this could be very handy when you're trying to write a new SLO, right? So the availability level you set or the threshold um, within a particular time frame, this is essentially what results. So let's say if you have a 90% availability level, you are really only allowing for 6 minutes of downtime within the hour before you go past your error budget. And in addition to this cheat sheet, you can just plug in whatever other percent that you want, and it'll give you some numbers that you could use in different time frames. So this is a cool tool that will give you an idea of um, a little more tangibly what you're looking at when you're writing out your SLO. So I might have forgotten to add this to the README. I'll add it to the README after this recording. Now let's switch over to Cloudwatch Agent. I've already set this up. So I wonder if, let's just run through it again, I guess. So I'm going to make a new EC2 instance, and we are going to do this from scratch. So it's already working on the EC2 that I set up earlier, but let's, instead of going through that and just talking through something that's already kind of finished, let's just make a new EC2. So we're gonna create a new instance. I'm gonna say Cloudwatch agent demo. We are going to pick, I'm gonna pick Linux 2 AMI, and I'm gonna pick T2 Micro. I'm gonna pick for our classes default key pair, and I think this should be good. Let's launch. And now what we're going to do is we're going to SSH into this container, or sorry, this EC2, and we are going to run some setup. So by installing Cloudwatch agent on an EC2, we can have our application, our theoretical application on this EC2, do some really cool stuff like emit metrics directly to Cloudwatch. Um, and this is how you'll be able to create metrics and monitor and observe things that you may not be able to with a built-in Cloudwatch metrics. So let's refresh. This should be ready. Let's go. We're going to connect. I'm going to drag over VS Code, which is kind of always very sloppy. Yeah, let's just open up a new session. Let's jump into our SSH directory, call this command, hit yes, and now we are on the EC2. So the first thing we're going to do is we're going to do some basic setup. So, like your sudo yum update packages, whatever. So I hate trying to memorize these, but sudo yum update y, or dash y. The update doesn't have a dash. And we could do, once this is done, sudo yum install dash y nginx. Okay, I must have selected a different AMI yesterday when I wrote this. So I think this should work. And it looks like it is. So I added that to the README. It's in the README now. Basically, if you're using a different AMI and it's not installing for you, just Google or ask ChatGPT exactly what command to run to install Nginx. Now that we've got Nginx set up, we could run a start on Nginx. And really, we're just doing this so that we could be able to have a landing page that we could see. It'll stand in for our application. And then we're going to enable Nginx. Now we are going to create a very basic, simple HTML page. Oh, no. So let's also make sure typos. Still getting it. Okay. Let's try sudo su. All right, now we've created this index.html inside of our Nginx configuration directory. And now we can just double check well, actually, before we double check the config file, this might actually be enough. So let's go back to our EC2 and let's grab our public IP. And let's take a look. HTTPS, so let's get rid of that S. No dice, apparently. Is this the right one? Yeah, Cloudwatch agent demo. Okay, let's go back here. Let's go ahead and take a look at our Nginx config. And I'm going to scroll down to where we have our location set. And let's see. I'm going to do try files. Try. And let's see, am I missing anything else? No, Good, let's save. Still nothing. Oh, let's take a look at our security groups, even though I feel like this should be set up correctly. Okay, we're gonna go to our VPC, or not VPC. I'm gonna go to our security group. Okay. We have, oh, we're using Launch Wizard. That's not what I want to use. Let's see if we can change our security group. What was I using? Oh, I'm blanking on what I was using. I think I was using this, so I'm gonna add that. I'm gonna save. I'm gonna refresh. And now we have Hello World. So that's our landing page for our app, and we can go back to our README, where the next step is to, we've just done this, create and attach an IAM role for Cloudwatch. So without this, you may not be able to get Cloudwatch agent running on your EC2. So let's go back to our EC2. Let's go back to our security settings and let's add an IAM role that was created specifically for this. So, nope, that's not the right one. This is the right one. Action, security, modify IAM role. And I think this one was named, oof, I have like the worst short-term memory. Oh, I think it's in the README. Let's see. EC2 CloudWatch agent role. Kind of self-explanatory. So let's update that. And from here, we could actually install CloudWatch agent. So back into our SSH session, let's do another sudo yum install, this time for Amazon CloudWatch agent. And while that's running, let's take a look at what happens next. We're going to create a configuration file using this command, and then we're going to add the following. So we're specifying an agent, and in that agent, we're gonna collect metrics every 60 seconds, and it's gonna record everything in this log file. The metrics is going to exist in a namespace called web app metrics, and it's going to utilize the instance ID of the EC2 that we are installing this on. And it's going to collect everything through statsd. Statsd is a simple daemon that was created by Etsy for metric collection. And this will allow us to use a utility like netcat to, well, in this case, netcat, because we don't actually have a real application to send metrics from, but we'll use netcat or the app in theory to send metrics over to CloudWatch agent to be picked up by the statsd daemon. And then we also specify what we want to collect, right? So we're going to be creating a metric for disk usage, and we are going to track the percentage of our disk space used. And again, this will update every 60 seconds. We could specify for what resource we want it, and we're just specifying that we want it for everything. So that's that. I think this should be done installing by now. Whoops, should not have seen those grades. Let's see. And what's I doing? Okay, right. I was creating this JSON. And here we are going to insert the following. So let's write, let's quit, and let's now start the CloudWatch agent. It's kind of a long, clumsy looking command. But here, let's talk through it. So we're using this path to grab this Amazon CloudWatch agent control file or executable, I guess, and passing in some arguments, including the file path of the configuration JSON that we just created. So let's hit enter. It's telling us that configuration succeeded, but it also stopped the CloudWatch agent. So let's just run it again, and it should succeed without stopping the agent. So now our agent should be running. And we're going to go ahead and install Netcat now so we can start playing. Well, actually, before we install Netcat, let's go back into our dashboard. Not necessarily an SLO, we could just do a plain vanilla. Oh, right, this is for, not for the other instance. So let's create a new dashboard. Yeah, let's save and continue. What did I call this EC2 instance? I already forget what I called it. Cloudwatch agent demo. So we're going to call it Cloudwatch agent demo dashboard. And we are going to, remember how we created a disk usage metric? We're gonna, because it's just a, I guess, a percentage metric, we're gonna use number to create a very simple widget for that. So let's select number, let's hit next, and where we select our metric, instead of going down to AWS namespaces, we're gonna go up to these custom namespaces, and we're gonna look for the one that we just created. It may take a while to populate as well, because we set it to 60 seconds, and then it's got to do CloudWatch agent magic stuff. So I guess let's go back to here and let's go ahead and install Netcat. Sudo yum install shwy for yes, Netcat. That should be relatively quick. It's a very light utility. And from here, we could throw in another very clunky looking command. It's this guy here, but instead of this, we're going to want our actual IP. So I'm going to grab this. We're going to go to whatever file that was in. And let's toss that in there. I don't want to save. Did that by habit. We're going to copy paste this into our command line. And it looks like it didn't complain. So now we can use tail to look at the logs for this, right? So we're going back to that CloudWatch agent log that we saw earlier. We're using tail with a -f to point to that file. And this should show us the tail end of the log file. So now we could see that our stats D is successfully listening in. And so if we start sending in some metrics, it will start picking those up. It'll still be slow because we set our interval to 60 seconds, but let's go ahead and let's spam that. Well, let me SSH back onto here. And so we could spam that request a few more times. Is the right one? CloudWatch agent demo, connect. Okay. So I have that here. Like I said, we could spam it a few times. And we could also try a different metric. So now we're going to create a metric called test metric. We're just going to send it as 100. And again, we're going to pass it into local, because we're on this EC2, and through the port 8125, because that's where our stats D is listening. NC is for Netcat, and we're passing in a few arguments for Netcat. dash W, I believe, is, it's a duration, and I think it's set to 1 second. So let's now spam that a few more times. And let's go back to our dashboard and see if we finally have any visibility on these. All right, so let's first go to number. Let's go back to web metrics. It looks like we have more than we did earlier. We now have our custom metric for our new Cloudwatch agent demo EC2. So let's select it. And voila, we have some data that is being picked up directly from the EC2 using statsd. Or sorry, not statsd in this case. What is it called? Cloudwatch agent, which I don't know, maybe might be using the statsd agent to talk to itself. But this is different from the metric that we were manually calling through echo, right? This is the one that was inside of the configuration. So that's that. Now let's look at another custom metric that we created. If we go over to this second category here, we should see that we now have our response time generating for Cloudwatch agent demo. Still no sign of the test metric yet, but again, this is just going to take a bit of time. So Cloudwatch agent demo, we don't see anything yet, but let's go ahead and create this widget because we should see something relatively soon. And then let's add one more for, all right, looks like we have another new web app metric. Or maybe I miscounted. Maybe we're still waiting, I guess. While we're waiting on that, you could play around if you haven't yet with any of these other things like adding math and adding queries, right? We don't really have anything that we can query, so let's see if there's any interesting math that we could use. This is I mean, we don't really have good data to play around with, but an example of some math that you could apply would be, again, to take, let's say if we were tracking the number of times a request was made, we could track the number of times it either succeeds or fails over the total number of times it was called to generate either a success or error rate. Let's refresh. Let's see if we have our new test thing. Okay. No, never mind. Jumped ahead of myself. We at least have some data now for the response time. That's finally populated. So that's telling us that we have a response time that was pretty much at 1 second. And let's see if we have our test metric populating yet. Okay, now it's up to 10. That should be the new test metric. And it looks like it is. So let's go ahead, create that widget. It's still blank for now. Looks like it's at 100, which was the value that we passed in. Let's see if we could pass in a different value, and that'll update. Right, this might take a while, but eventually it'll pick up and it will update. So any questions on any of this?
Hey, Julius, is there a repository for scripting or code for the NC that you installed and the different elements? Are you aware of like a Git repo or just some standard libraries where these sort of scripting tools can be found?
Oh, like a resource page? Not really. I mean, I track a few like resource collections, but I don't have any good ones to recommend specifically for what you're asking for.
Yeah, it's that, turning an indicator into a metric or into a service level objective. dashboard. It's that transforming of that data into manager level, management level side to it.
So yeah, I don't know if okay. Let's take a look at, I don't know, let's take a look at um let's see if we could find anything. I think I did add a link to some SRE resources. So it's got a lot of stuff though. This is why I don't really like large resource collections. It's not really helpful if it's just dumping a crap ton of data on you. I mean, that's essentially creating buffer bloat, right? Like how are you gonna learn anything if there's too much to learn? So let's see though if we could pick out anything that's going to be useful here pertaining to your request. So we are looking for, I don't know, how to gauge what metrics to create for good monitoring, something like that, right?
Yeah, exactly. Like the other lesson from Chandra, I was Googling, what are my standard Linux server logs that I would want to create indicators around. And so today I'm asking like the next level question here related to your lesson of, what are some standard code snippets that translate running indicators, so sample rates and whether you're looking at the tail or the head of a log metric, turning a log into a SLO dashboard
Okay.
is
We're not really turning a log into an SLO dashboard. Like you're these are all I think you could think of them as like components, right? Like they are different actions that can be combined in like an infinite number of ways. So when you get to like the point where you're trying to create dashboards or service level objectives, you have to know your applications in and out well enough that you know what those individual components are, right? You'll want to know what logs to look at for certain things, but even then, you're not necessarily looking at the logs for these metrics. You have something else inside the application that's going to be creating this metric, right? Like let's say in your code base, where you have the API call being made, that's where you could use like a Datadog. You can invoke a Datadog agent command to emit that metric over to Datadog. Same with Cloudwatch. You could use a command to emit that metric over to Cloudwatch through the agent. So it's hard to answer your question because it's a hypothetical, right? A very generalized hypothetical, but it boils down to knowing your application inside and out. Does that help?
I think that is straightforward and very true, right? And I agree with you, hypothetical and the realistic, tangible. Um, I do wonder if there are a set you can boil down to a set, like for example, CloudWatch and some of the alerting and monitoring that we see in the cloud already come with canned indicators, right? So it feels like there is a set of basic health and status indicators that most stacks will employ or could employ and would give you a generic, like at work, we're doing something silly with ping tests, and just trace routes and building a dashboard off of something generic like that to try and get us where, one level up from nothing.
Yeah, but you need to be intentional about how you utilize the data that you're trying to build, like alerting and um, monitoring around, right? So here are like let's go back to like some key objectives when it comes to like making SLOs or really monitors, general monitors. Like these are probably, to answer your question, the things that you'll want to look for in virtually every application, right? You want to be able to check to see if it's available. A ping test work, could work for that. A ping test could also or let's say maybe more like a host command that will actually a ping test. Yes, let's go back to the ping test because that could return like the number of packets lost over time, right? So that could help you track your latency. Throughput, not necessarily sure if, I mean, I guess in theory, you could have pings coming from a bunch of different sources, and that could help you test throughput, right? So it's a combination of the commands, the metrics that are created from these commands, or that you could, I guess, collect based on these commands and their actions, and how you utilize them. Like there's more ways than one, right?
Yeah. Yeah, absolutely. Yep.
Cool. So if you are curious about like reading more, definitely try to try to get through this really long. I mean, not get through, like read through the whole thing, but maybe just take a glance at this really long SRE resources thing and see if anything sticks out to you that might be interesting. It talks a lot about different parts of SRE and DevOps in general, like culture. Postmortems are big for incident management. Like that's a big part of the culture as well. It's another aspect of management that SRE kind of well pioneers, I guess, for lack of a better word. Yeah, there's a lot on culture. There's a lot of on education, books, a smaller section, so probably an easier to digest section specifically for hiring. So that could help with interviews and interview prep and just learning more about reliability in general. Was like, yeah, again, there's a lot here. I don't know if any of these really look familiar to me. Chaos engineering is a very fun topic. That's another area where SREs, another SRE domain, basically. It part of incident management, which in a way utilizes service level management, is to be able to test um, how effective your SREs are at responding to an incident, right? So things like chaos engineering allow for creating game sessions, right? Like at Innova, we call them game days where we will create chaos through simulated production incidents and we'll test a software engineering team's ability to respond to those incidents. I think there's a really cool, yeah, there's a really cool app here that's that I've been interested in, like maybe hijacking and repurposing for Platoon, but this is the wheel of misfortune. If you spin the wheel, it's going to name a random incident. So this is supposed to be played by a small team, a small group of people. You'll have one incident manager or game master, essentially, right? That will be able to see all of these different scenarios. And then you just have different people on the team playing the game, spin the wheel. And when they have a scenario, they'll have to talk through how they would solve that. Like you would, and you as the game master would say, okay, they've acknowledged it, then we could skip that step, or not skip, but like approve that step. Then you have to talk through how to mitigate the issue, then how to triage, and then how to resolve. And that's essentially what game days are. So cool little app for doing that. So yeah, lots of cool stuff on here. It's a lot to digest, but it's here if you want to look at it. All right. I definitely think I went over. Um, Hopefully didn't put too many folks to sleep. Catch up on the assignments that you've had from last week, assessments if you're still working on them. Um, yeah. And we will have, I don't really know if there's anything to have stand down for later on. So why don't we just maybe take it easy today? Um, you're adults, work on what you need to work on, and let's just communicate on Slack for anything that y'all need. Sound good?